So to start Simulink, you can click on this icon, or you can also type Simulink in command window. This is Simulink startup page. To start a blank model, you have to click on this icon and then click on create model. So now a blank Simulink model is created. We have to first add transfer function block. For that, you have to click on this library browser. You can see there are various blocks inbuilt in Simulink. You can use from it. We have to use transfer function block. We will search for transfer function block and press enter. So this is the block that we need. Simply click on this and drag to our model space. So now double click on this transfer function block to see its property. So in this transfer function block, we need to add the numerator coefficient of our transfer function and denominator coefficient. So the numerator coefficient is 1488.4 and denominator coefficient is 1, 0 and minus 30.5 whole square. 1, 0 and minus 30.5 whole square. Then click on apply and OK. Next we need scope to see output. So again you can click on this library browser and search for scope. Press enter. Then drag and drop to our model space. Then connect output of transfer function to this scope. Next we need gain for our proportional controller. For that, double click. You can use this library browser icon, or you can also double click and search for gain and then click enter. So this is gain. I will change its label to KP. Now I will add another gain for derivative controller. And change its label to KD. And gain for integral controller. I will change its name to KI. Okay. For derivative, we need derivative block. So for that, double click and search for derivative block. And then click on enter. So this is derivative block. For integrator, we need an integrator block. Again, double click and search for integrator block. So now we need a summation point to sum proportional signal, integral signal and derivative signal. For that, double click and search for summation point. Press enter. We have to add this three signal. Now you can see here is only two signals are there. So we need to add one more signal. For that, double click on it and add one plus sign. Now click on apply and OK. Now connect this signal to the summation point. So this is KP. and then connect it to our transfer function input. Okay, we need unity negative feedback here. For that, we need one summation point here. Click, double click and search for summation. Now we need negative unity feedback. So for that, double click and change its sign to negative. Click on apply and then OK. Now I will connect this feedback here. Now I will connect this error signal values to KP, KI and KD. Okay, now we need input. Here we are going to use step input. For that, double click and search for step input. So this is step input block. Double click on this block to see its property. Here you can change the step size, initial value and final value. Final value is the value of required position of wall that we need. Here I am going to set final value to 1 and then click on OK. Now I am going to connect this input to our system. Now to visualize this output as well as this input, I am going to add one more terminal in the scope. For that, double click on scope, files and number of input ports. I am going to change it to 2. Okay, and now I am going to connect this input to the scope so that I can see the input value as well. Okay, now I will change the gain values. I will set proportional KP value to 4. Click on apply. Okay, and then KD to 0.2. Click on apply and then OK, and then KI to 0 0.4. Click on apply and OK. So next step is to simulate this model. For that you have to click on this run button, then this model will be compiled and we will get a result. So I will click on it. Now the model is compiled and we are going to see the results. So this is the result. As we can see, the required value was 1, but our system overshoot above 1. And then I will increase the simulation time from 10 seconds to 30 seconds. Now I am going to simulate again. So as you can see, there is some initial overshoot and then it approaches to the required value of 1 here.